Hey there, this is Mike from the UX Dev Summit, and we're continuing to talk about developing Alexa skills and discussing Alexa capabilities. There is a long list of capabilities. Capabilities are interfaces which allow you to either develop or integrate with using a set of predefined elements or contracts. These interfaces are agreements essentially between two different disparate systems. As an Alexa developer, you may implement interfaces, and if you are creating, for example, an IoT type of device, you may support these types of interfaces by implementing it in such a way so that Alexa can communicate through these devices using that agreed upon contract. All right, so with that said, we're going to get started on our next capability interface, which is the color temperature controller. Now, the Alexa color temperature controller interface describes a message that's basically to used to control and report the color temperature of an endpoint. So, for example, it's a way for us to change a color's brightness from, say, white to something else. So, for example, maybe we're going to lower a Kelvin temperature value of a device. This directive does not specify a specific setting, but asks for a warmer setting relative to the current device setting. You can choose how much to adjust the setting of the specified device depending on its current capability or current value. So essentially, this allows us to change and adjust the temperature of that color to a different element or to a different level. So we can use in this case, the directive called the decrease color temperature. So I know that that former slide was a little abstract, so it usually helps when you can see an example. So in this case, if you take a look down at the bottom of the slide, you have Alexa, set the device name, whatever that is, warmer or softer. Alexa, make the living room warmer. So you can imagine that you have a setting on your light which is a little more dimmer. So when we use this term warmer, it actually will make it brighter. If we say softer, it will actually dim the light, and that will be relative to the current setting or the current brightness level. So remember we said we could use a specific value. Well, here is a chart to kind of help you kind of grasp that overall idea of warmer or softer and what that looks like essentially from a numerical value. So it's possible to set that color temperature of the specified device to a specific setting. Now, this is a lighting chart which is going to show you what values are supported. So on the left side, you see warm, warm white, soft white, white, daylight. You can kind of get an idea from those loose terms on the right side exactly how bright that element is going to be. So for example, if we said warm, we would be looking at a Kelvin value around 2200. However, we said something like a cool white, now you're really talking about a very bright white, which is 7000. And all of these different terms are essentially mapped to these values. So when we're interfacing with a device that implements this color temperature controller, we can really adjust that level of brightness. Another major area you're going to find that Alexa provides a lot of capability interfacing is for cooking. So whether you are developing applications within the Alexa skill side of interfacing with a cooking type application, or on the manufacturing side where you are trying to conform to an existing contract, Alexa provides a lot of interface capabilities to support this. So you might want to think in your mind microwave, even an oven, or perhaps maybe like a stovetop, or even coffee maker. Start thinking about all of those different types of things. Now, obviously, when you are developing with this stuff, there is a huge level of responsibility to take as the developer of either the supporting mechanism or implementing the manufacturing side. This is not something you want to have bugs in. You should definitely treat all of this stuff like mission critical software. If you're unfamiliar with what that means, it's 99.99% bug-free, code-free, there is really a small, minimal amount of error involved. Now, luckily, they abstract a lot of that functionality for you, but this is definitely not something you want to like have no idea about. You definitely want to develop really good stuff, because this can burn someone's house down, or you can start fires. There's a lot of liability issues or concerns when you are even considering working with this. So definitely treat this stuff with the utmost respect, almost like you would with, say, a weapon of some sort. So with that said, and all of that disclaimer stuff said, the Alexa cooking interface is the highest level interface which Alexa provides, and it basically describes how to direct cooking type appliances to perform an operation, and should be implemented by all of those cooking appliances. So you could think in your mind some type of appliance where there is a set cooking mode directive that's supported. On the Alexa side as well as on the manufacturer side. Now on the manufacturer side, it's probably a lot more lower level, it's maybe assembly or some type of lower level language, but at the high outermost online API exposed endpoint, it still implements that contract. In other words, there is still some type of set cooking mode that is exposed universally out there to the world. Now what happens from that point maybe gets decompiled into assembly, etc., all of those types of things where you start sending signals to the appliance, more things like that. So for example, in this case, as we were talking about, the prerequisites obviously are being able to discover that device. So Alexa has to know about these online appliances. There has to be some type of discovery process that occurs so that she knows she can communicate with a microwave. Also, another thing you might think about is, obviously there's going to be multiple types of directives that are supported. So one directive would be the set cooking mode. In this case, we can set a type of cooking mode that you might find in an appliance. The most common one, obviously, that comes to mind would be a microwave. But there's also the stove as well, where it has bake or boil. You can think about meat or defrosting, all of those types of things that you might either see on your microwave or you might see on an oven, for example. So in this case, we have the example at the bottom where it says, Alexa, defrost 3 pounds of meat in my microwave. Now she would take that request and she would essentially communicate with that microwave, assuming that it has been discovered, and she would send the directive or the instruction and the message which contains the cooking code that would essentially tell the microwave that you want to defrost 3 pounds of meat within that microwave, for that duration. And that would be essentially how she would discover that. So the next capability interface we want to discuss is something that hangs a little lower down the interfaces. Remember I said that Alexa.Cooking is that highest level interface. There are also some interfaces that sit a little beneath that. So as you can see from the nomenclature, the highest is Alexa, the second is Cooking, and the third is the error response. Now, as you might imagine, when you're dealing with some type of appliance or various appliances, depending on how you are integrating with them, you need a way to handle errors. Now, if you think about what I was saying, where there's all of these low-level languages, all of these specific manufacturers, and all developed by different vendors, they probably most likely have their own types of response messages or response errors, right? And all of those different error messages. So how do you essentially have a universal way to communicate all of that information back to Alexa? Well, that's where, in the case of an error happening or something not going right, that's where the error response comes into play. It provides that high-level exchange between, remember I said there were two systems, and a contract, which is an agreement between both of those systems, where that information can be sent from one endpoint to the other. So when you have an error response, right, and the manufacturer from, say, appliance A, company B, and on another an appliance, which is a completely different appliance, but also is developed by a complete different vendor, both of them may have implementation logic that's specific to their organization or specific to their brand. They may have different practices and principles in terms of the way they handle errors. All of that information can be universally handled at a higher level through a common thing like an error response. So errors message formats essentially establish that type of universal format that all of these different things can communicate in a common vocabulary way, so that Alexa on the AWS ecosystem side of things, she can handle all of that information appropriately. So for example, right, this error message format establishes that contract, right? So you can think of that contract as a format or a type or a structure, right? And this agreed upon structure, in order to interface with that, with those different systems, is a universal way for both things to communicate properly. So one of the things that may be helpful walking through this, if you are listening and following along, is just kind of take your laptop or even your phone and kind of go to the kitchen and take a look at the appliances that are around you. Now think about all of the different types of devices and all of the different types of things that you might need to know about those devices. Remember that when you are Alexa, or your persona is of Alexa, you don't physically see this. You can only communicate through signals and through response codes. And I think you'll quickly start seeing the types of things that might be involved, when you're interfacing with these types of systems. So, like for example, when you're looking at the message codes, the beautiful thing is that they are pretty straightforward in terms of what is going on. You can read on the left side, you have a door underscore open. I think, that's pretty self-explanatory. It indicates that the operation couldn't be attempted because the appliance door is open. So you can't start the microwave, right, unless the door is closed. That might be a situation where you're running into a problem, right? And think about users, right? Your user might not be the most focused or attentive because they're now relying that mental concentration more on Alexa. So they might kind of not be paying attention to things like, they may walk away with the microwave door wide open and be like, Alexa, microwave lasagna for 20 minutes, you know what I mean? And if these things were not supported, then you'd be in a lot of problems, and Lord knows what would happen from that. So again, just try to think about all these different types of things that could be going on as you are thinking about different ways and different things that this stuff supports. So door closed too long. So that indicates the request operation could not be completed because the door has not been opened and closed recently, indicating that the appliance is likely empty. So that one's kind of a weird one, but I suppose it could happen. Definitely something you want to think about. Okay, the next one we got is the remote start not supported, and this indicates that a start cooking directive was rejected because remote start is not supported on the targeted appliance. Note that in most cases, you will report whether remote start is supported at endpoint discovery time, but if the device capabilities change after discovery, you can return this error. So think about an update, right? So there's might be an online system and you do a software update. That might be a case where Alexa recently discovered the system, but then an upgrade occurred and this upgrade was incompatible with this interface and has broken that interface. That might be where you might run into that situation. Remote start disabled indicates that the remote start on the appliance was disabled and must be re-enabled before cooking can continue. So imagine you have, maybe you have two different intranets and your intranet goes down, or, the internet is down altogether and you are trying to communicate with that device. Maybe the system goes offline. Maybe, it's running on battery power and it shuts down. Try to think of all those different types of scenarios where, essentially the system goes offline. That's where you would probably run into this one. And so error types are not specific to a capability interface and can be used to respond to any control or query directive. So that's what's really cool about them. You can use them across all sorts of different types of use cases. If an error such as an expired token occurs during a discovery request, return an empty endpoint array and not an error. So this is kind of like a best practice from Amazon and Alexa. This is kind of how they want you to handle that. Errors that are specific to capabilities are also supported. So if you have a specific situation where an error occurs, that will also be possible using this type of interface. Thanks for watching this video and along with all the others. Truly appreciate it. I'm going to go ahead and stop here. We have a number of capabilities that we still need to cover. We're going to continue going through the cooking capabilities, as well as some others that will be available to you, just to kind of, again, give you this high level idea of all the different types of things you can work with and interface. Hopefully by now you're really starting to see how many things you can integrate with, how many things Alexa can be used for, all the different types of things that are around us that Alexa can actually interface with. So very cool technology, a lot of really cool capabilities. You know, exciting stuff. So thanks for watching this. Hope to see you guys next time. Take care.